My name is Vidhi, and I'm currently an honors student in the Department of Psychology. And today I'll be presenting on the effect of wildfire smoke exposure on the infant gut microbiome. So, over the years, Canada has seen an increasing frequency in wildfires, with the recent 2024 Jasper wildfire being one of the worst wildfires Canada has experienced in the last 100 years. With this increase, larger smoke plumes are produced, and as their size increases, they travel further across provinces and affect air quality for longer periods of time. Therefore, more and more Canadians are being exposed to wildfire smoke for longer. This is important because smoke exposure doesn't just affect the lungs, but rather it has been shown to have system-wide effects on the body. These smoke particles, namely molecules that are less than 2.5 microns in size, can enter the bloodstream and cause low-grade systemic inflammation. The systemic inflammation can then alter the microbiome's diversity and composition, and this is especially impactful as the microbiome consists of microorganisms that can influence brain development, digestion, and immune function in infants. So, given the potential impact on neurodevelopment and the body as a whole, it is important to study exactly how wildfire smoke exposure affects the gut microbiome. Recent studies have identified a decrease in the diversity of the gut microbiome following exposure to secondhand cigarette smoke and acute and chronic air pollution. However, despite this existing research, there have been no studies to date that specifically explore the impact of wildfire smoke exposure on the infant gut microbiome. So, we're actually the first in Canada to look at this association. Given the microbiome's connection to multiple body systems, we chose to investigate the impact of wildfire-associated smoke exposure on infants specifically, as exposure during critical developmental periods in infancy may influence later stages of development. The aim for this study was to investigate how gut microbial diversity differs between infants exposed and not exposed to wildfire smoke, with the sub-aim being to investigate if the degree of smoke exposure relates to a larger change in the microbiome. The hypothesis was that wildfire smoke exposed infants have an altered gut microbial diversity relative to the comparison group. For our methods, stool samples were collected from 310 infants via the pregnancy during the pandemic study, as well as their postal codes from the years of 2020 and 2021. Postal codes were then linked to PM 2.5 levels, and these data were then used to group infants into two groups, wildfire smoke exposed or the comparison group, depending on if a PM 2.5 cutoff of 9 micrograms per cubic meters was being met. Lastly, we obtained the gut microbial diversity for each infant via analyzing their stool samples. For aim 1, we conducted an ANCOVA to assess between-group differences in gut microbiome diversity between the wildfire smoke exposed group and the comparison group. For the sub-aim, we performed a partial correlation analysis to examine the relationship between the degree of wildfire smoke exposure and gut microbiome diversity. In both analyses, we controlled for key variables, including season and region of stool sample collection, as well as the infant's age at the time of collection. And here are the results from my analyses. So each dot here represents an infant, and infants are grouped by color, blue being the comparison group and red being the wildfire smoke exposed group. Smoke exposure is plotted on the x-axis, while gut microbial diversity is plotted on the y. And when we do a group comparison, we see the gut microbial diversity of wildfire smoke exposed infants to be significantly lower than the comparison group. Such results are also observed when we test the effects of the degree of smoke exposure on gut microbial diversity, where increasing smoke exposure is significantly correlated with a decrease in microbial diversity. So in sum, wildfire smoke exposure is associated with reduced diversity of the infant gut microbiome. And in fact, we saw a significant correlation where greater exposure to wildfire smoke is linked to greater changes in the infant gut microbiome. And this is deeply concerning, especially as North American climate patterns show a steady increase in wildfires each year. What makes this even more critical is the glaring lack of research in this area. Paired with the rising frequency of wildfires, we are faced with a growing unknown. We often focus on the immediate, visible consequences of wildfire seasons, but what's overlooked are the potential long-term effects on child health, which may only manifest later, long after the smoke clears. And to progress in this direction, we can further this research by understanding this impact of wildfire smoke exposure on child neurodevelopmental outcomes. And these are my references. And I would like to firstly thank Pure for giving me an opportunity to work and learn under Drs. Van der Waal and Giesbrecht. I would additionally like to thank the Pregnancy During the Pandemic leads, coordinators, and collaborators for providing the pan-Canadian dataset I use in my study. And lastly, I'd like to thank the Student Union for giving me the opportunity to discuss my research. Thank you so much for listening.